This video will give examples with logarithm properties. Put log base 3, 54 in terms of a, where a equals log base 3 of 2. To do this, we're going to have to use the product property. So first, we need to note that 54 is equal to 27 times 2, or 3 to the third times 2. So now we can rewrite our logarithm as log base 3 of 3 cubed times 2. Now we can use our product property to expand this into log base 3 of 3 cubed plus log base 3 of 2. Now we know that this is just equal to 3 by our inverse rule. And then we can just copy down log base 3 of 2. And since we're given what that equals, it's a, we can just write 3 plus a. Put log base 4 of 3.5 in terms of a and b, where a equals log base 4 2 and b equals log base 4 7. So we can write 3.5 as 7 over 2. And now we can use our product of logarithms, log base 4 7 minus log base 4 2. And now we can just plug in the variables that we were given, so b minus a. Sound is measured in decibels, with d equals 10 times the log base 10 of r, and here we have d meaning the decibel measurement of sound, and r equals the relative intensity of sound. So an old lady complains if noise is louder than 10 to the third relative intensity. The sound of one drum has relative intensity 10 to the sixth. How many times louder than the lady's tolerance is the noise for my band, which has 10 drums? So we're going to convert our relative intensities into decibels using our formula. So decibel T, that'll represent the tolerance level of the old lady. That'll be 10 log base 10 of 10 to the third. And then decibels from one drum will be equal to 10 times log base 10, 10 to the sixth. So that means that the decibel of my band is equal to 10 log base 10 of 10 times 10 to the sixth, because where I only have one drum here, now I have 10 drums. Okay, so I want to subtract the loudness of my band and the tolerance level of the old lady to see how much louder my band is than she can tolerate. So that's equal to 10 log base 10 of, I'm going to combine this as 10 to the 7th, minus 10 log base 10 of 10 to the third. And so using my properties of logarithms, I can rewrite this as 7, and I can rewrite this part as 3. So what I end up with is 10 times 7 minus 10 times 3, or just 40. So my band is 40 decibels louder than the lady can tolerate. So I'm going to have an angry old lady knocking on my door. Solve 2 times log base 2x plus log base 2 3 equals log base 2 27. First thing we can do is we'll move the 2 into the log. And then we can use our product property to combine our left-hand side into one expression. So we have x squared times 3 And now that we come here, we can see that these two expressions must be equal. So x squared times 3 equals 27, x squared equals 9, x equals plus or minus 3 if we want to solve this. However, we cannot take the log of a negative number, so our only solution ends up being x equals 3. Solve this equation. Here we'll use our quotient rule first, so log base 7 of 2n plus 3 over n minus 1 equals 1. Now what we can do is rewrite this in exponential form, so 7 to the power of 1 equals this element here, or 7. Okay, and so now we can just use regular algebra. 2n plus 3 equals 7 times n minus 1, or 7n minus 7. And so that gives us 10 equals 5n, or n equals 2. And here again, we want to make sure that having an n of this value keeps the property that all of these are greater than 0. So 2 times 2 plus 3 is greater than 0, and 2 minus 1 is also greater than 0, meaning that we have found a valid answer.